My name's Derek Hullinger. I have a PhD in physics, and I'm going to explain the connection between the number of electrons in an atom and how much an atom weighs. So an atom is made up of protons, neutrons, and electrons. The protons and the neutrons are inside the nucleus, and the electrons sort of orbit around the outside. The protons have a positive charge, the electrons have a negative charge, and the neutrons don't have any charge at all. And usually, unless the atom is ionized, however many protons there are with a positive charge in the nucleus is exactly the same as the number of electrons that are going around the nucleus. So in an atom, there are a few key numbers that describe the relationship between the number of electrons and the number of protons and such. And the most important is called the atomic number. The atomic number is just how many protons there are. And usually they use Z to represent that. So if you know how many protons there are, which for an unionized atom is also the number of electrons, that tells you what kind of atom you have. For example, Z equals 1 is hydrogen, Z equals 2 is helium, and so on. Another important number is something called the neutron number. And you can probably guess from the name of it that it's just the number of neutrons that the atom has. And usually a capital N is used to describe that. So say two different nucleuses have the same atomic number, but a different neutron number. They're the same element, but different isotopes of that element. And then finally, there's something called the mass number. And that's just the combination of the atomic number and the neutron number. And they usually use an A to give that number. So let's look at an example. Ordinary hydrogen. Hydrogen is the simplest atom that you can imagine. It has an atomic number of 1 and a neutron number of 0. So its mass number would be 1, because that's just 1 plus 0. There's another isotope of hydrogen called deuterium. And just like hydrogen, it has an atomic number of 1, but its neutron number is also 1. So its mass number would be 2, 1 plus 1. Tritium, on the other hand, has an atomic number of 1 and a neutron number of 2. So 1 plus 2 is 3 for its mass number. All three of these are different isotopes of hydrogen. They all have the same atomic number, but they all have different mass numbers. One thing that you'll notice is that the mass number is always greater than or equal to the atomic number. So if you know how many protons an atom has, and by extension, how many electrons it has, you can guarantee that its mass number will be bigger than that or the same as that. Usually bigger, because most elements, especially above hydrogen, have some neutrons too.